Woot, woot, woot. From a technical aspect, my nice little OpenCV web app object detecting with dynamic bounding boxes is finished. So the problem that I've had is I've been using OpenCV. OpenCV is an open source computer vision framework, and I've been using that on my little vehicles to basically have my vehicles try to track an object. The problem that I've noticed is that OpenCV works well, not necessarily great, and I don't really understand truly what OpenCV is actually seeing, what it's actually pinging off of. And so basically what I decided to do is I decided to create a web application here that allows me to actually see what OpenCV is basically pinging off of, right? If it sees an object, what does it think that object is? And so what this web app allows me to do is it allows me to upload pictures. These pictures are then run against OpenCV. OpenCV then says whether or not an object was detected. It gives me the coordinates, and then I dynamically build this web page using JavaScript to then create the bounding boxes around the particular object. So this does a couple of things. One, it shows me whether or not something is being detected in an image. It shows me exactly where the object is being detected so that then I can understand what false positives looks like. So false positives is the problem where it thinks it is something, but it actually isn't that thing. And so that's what we have with this little web application. So up here, basically you can say what cascade you want to use. So that's the filter that you use. And then you can add files, right? So I can choose files. I can just, let's see, I'll try to select, here for a second. I'll just select a whole pile of pictures here. I will click upload so that they will be able to upload. So we are hopefully uploading about 24 pictures. We are going to scan it against the cat face. Do we have any cat faces? And then we're going to process the pictures. And that's going to go through. All the files are now being uploaded to my web server. It's all getting processed through. And my web server is a little janky, so the images, it gets a little quirky. It detected. Come on. Give me what I want. Oh, why is it doing this? Janky web server. There we go. My janky ass web server. That's its own issue. Again, that's one of the big problems in the technology world. It's like, where is the issue? Is it the PHP code? Is it the Python code? Is it the JavaScript code? Is it OpenCV? Is it the actual web server itself? That issue is the web server, but oh well, I just have a crappy web server I'm dealing with. So anyways, so I uploaded those 24 images. I'm asking what a cat face looks like. So it says the cascade filter. It says frontal cat face. So this tells me what it's supposed to be looking for. And we can already see problems, boys and girls. Thank God I'm asking about cats. Thank God I'm asking about cats. It thinks that wonderful person is a cat. It thinks that wonderful person's nose is a cat. And again, that's the interesting thing with the bounding box. You'll notice, it thinks his entire face is a cat, where it just thinks her nose is a cat. White person, yay, that's a cat. There's a cat. Peanut's nose, it detects as a cat, right? And then images without the object, and it shows the cat wasn't detected, right? And so, yeah, like I said, that's where we can go through and we can start looking at things. So if I don't upload, I can just actually scan the files, the pictures that have already been uploaded. And what do we want to do here? We have glasses. Oh, I don't know. Let's do the frontal face alt, right? And then we can simply process the pictures we already have. And this scans through, and so the drag guy, we see his face comes up pretty well. My crappy ass web server. Their face comes up again. Yay! It's both a cat face and a human face. You'll notice her. Before the nose is what triggered. Now her entire face comes up. Her entire face comes up. All three of those faces come up. My face comes up, and the yaks. whatever, right? And this is the important thing, to understand what the false positives look like, to try to get rid of it, right? And then my face there doesn't get detected, that person's face doesn't get detected, all these other faces don't get detected. Let me do one more thing here, right? So one of the things I think is interesting, again, looking at the issues, if we do choose files, so I'll do the choose files again. Let me go to downloads and pull some of these up that I downloaded. I'm going to upload them. And one of the things that I think is very interesting is the weird issue of, where was it? It was like upper body, which was very curious. So upper body. So this is supposed to trigger upper body, right? So we're going to process pictures. And I was curious to see what the false positives here look like. I think I still have these same images in the image set. Okay, so I uploaded all these pictures, and my janky ass web server is being a pain in the butt right now. So anyways, so we go down to this picture, right? So what you'll notice is, again, when we start talking about what does OpenCV actually ping off of, you see this shape. This shape seems to be what OpenCV thinks a upper body looks like. Again, and that's a curious thing. And this is the important thing with understanding false positives. You look at that shape that it thinks is an upper body, and then you look at that shape. There's something about that shape. And again, if you look at this cow, right, that black has that same kind of like soft triangle thing. So you can start to see like where the issues might be for things like false positives, especially if you don't have a janky ass server. Like her, look at that, her forehead. So horrible. Not me, right? But her forehead is actually pinging off as being an upper body. And then these folks down here, it's not detected. The cat's eye, yeah, I noticed that. So if you look at that cat's eye, if we zoom in, let's say with the cat's eye, you'll see how it has that same triangle look. And so that's where you can see it's something about that triangle look that the OpenCV is pinging off of. And then this person, hey, wow, we actually get an upper body. So that's this app. The problem that we have now, and again, this is the one thing to show you folks, where there's a lot more to an app than just simply the technical part, is you'll notice all of these images are showing up at full size. So some images are really big, other images are a little bit smaller, other images are even smaller than that. So basically what would need to be done at this point is kind of like the user experience, the designer type person would come in and start figuring out what sizes these images should be. So my issue with this is currently the canvas gets created. So all of this is being dynamically drawn on an HTML canvas. So JavaScript dynamically puts the image on the canvas, and then a canvas, JavaScript then draws on the canvas, right? So there's math, right? So I have the XY coordinates with the height, or the width, height, pixels. And so my issue right now is, even though this is functioning properly, if I wanted to have this image display smaller, I would then have to, within the HTML or within the JavaScript, I would have to shrink the image. But then as I shrink the image, shrinking the image is no big deal. But then as I shrink the image, I would then, at the same proportion, have to change my Y coordinates. So if this image is going to be 25% the size, so if I want to display an image that's 25% of the original size, then the X coordinate has to be 75% less than it originally was. The Y coordinate has to be 75% less. The width has to be 75 less, right? So it'll actually all shrink down. And that's when you get into the whole UI, UX deal. And that's where, for somebody like me, it's like, well, do I really want to do that much work? Is that all the work that I want to be doing? If you want to see the back end, how this all works, it's only five scripts here, right? So I have the index. So the index here, this is what draws everything on the canvas. So up at the top, I include my upload form. So that thing that allows me to upload. here I have the information for the cascade that we're using and other things. And basically what happens is this goes through and it looks at the pic-data file. So that file is created by Python that has the pictures and it has the coordinates of all the objects that have been detected. And this goes through and then it dynamically, we find out what the coordinates are, and then we actually draw out that canvas there. We have an upload form, basically just a pretty standard HTML upload form. Then we go to pic upload PHP. So when you upload, basically all this is doing is just taking that filter that we put in, so what filter we're going to use, and then it actually uploads. It uploads all the files to the server itself. Once it's done uploading all those files, we then do shell exec to trigger this Python script to run, so the OpenCV process. So this is triggered to run, and then basically when that is completed, this automatically redirects you to the index page. Take a look at this, and basically it's a lot of paths, and what we have here is essentially for all the images. So for all the images in the folder, it will scan them. If an image has an object in it, it will write to the text file the image name plus all the different coordinates. If an image isn't found, or if the object isn't found in an image, we have a neg data file. We'll just put the picture there. So that's where here, so these pictures have the object in it, and then we'll see down at the bottom, we just see a pile of pictures that don't have the object. So that way we can see what the positives are, and we can still remember what the negatives are. So that's why we have that. That just gets written out by the index.php thing here. And then over here we just have delete pics. So for this, if we just want to get rid of the images, let's say we can keep processing, right? So I have these images already uploaded. So once they're already uploaded, I can just keep processing again and again and again and seeing what the different results will be. My janky server. So full body, or yeah, so Har Cascade full body, and I think that's a full body. What does it think on here is a full body? I don't know. I think something on there is a full body. Where is it? God damn it. Nope. Hold on. I don't know. Her crotch. Her crotch is a full body. I can't make this up. An udder is a full body. All right, so anyways, I can keep processing, but if I want to get rid of them and start with a new data set, I can just do delete uploaded pictures, and it gets rid of all the images. Basically what we do here is we go to delete pics. I use shell exec, and basically I delete everything in the upload directory, and then these data files that I have, I basically just delete everything in those data files so we can start clean again. And then from here, like I say, we can do frontal face, and we can choose files, and we can go to desktop, and then we can see something that probably has a frontal face. Yeah, let's do that. And then we can process the picture, and janky ass web server. There we go. And so we have frontal face. So we can say, okay, that's detected, that's detected, that's detected, that's detected, that's detected, that's detected, that's detected. Yay. So anyways, look at that. Not quite a janky ass web app completed. So now we can see what computer vision is actually seeing. What I can do with this past here. So this is all using their built-in cascade filter. So when you download OpenCV, they give you this pile of cascade filters for you to use. As I've shown you folks before, I've actually trained my own data set using Lewis's logo. So what I can do going into the future is I can add Lewis's logo to this. Then I can upload a whole pile of pictures with Lewis's logo on, in the pictures, and then I can start to see like where does the detection fail? Does detection fail because of light? Does detection fail because of angle? How does detection fail there? That's where we go from. But again, one of the other things I really do want to hammer home is basically this whole idea of user interface, UI UX. A lot of people give UI UX people crap that they're like not real tech people, but I'm telling you, nobody will want to use your app. Nobody will want to use your app if you don't have good user interface design. So like with this is all technically working, and it gives me the information I need. I know I'm using this cascade filter. I know what image it is. I know the size of it. I get all the coordinates for where the faces are, and then I get dynamically, I get to see the bounding boxes for the face. But come on now. Come on, I'm not gonna lie. This thing is pretty dirt ugly, and especially once you start I don't know, using too many images, right? You can process the images, but once you start getting more and more and more images, you just get this problem with the size of the image and all that kind of stuff. So that's where you'd have like a UI UX person come in, and they'd figure out what the size the canvases should be and the whole 9 yards. Oh, stop being janky. Stop being janky. There we go. I don't know what's wrong with my web server. There's something going on. That's its own process, right? So anywho, there you go. There's the web app with OpenCV. Woo! And with that, it is quite literally Friday. I'm going to go home. I'm literally going to go to the circus tonight. So I'll see you all later.